Welcome, welcome, welcome to Correct Science. Today we are going to explore an amazing concept in mathematics and physics, vector product. Vector product, scalar product, we hear these things when we talk about vectors. What's the difference? Vector product produces a vector, while scalar product produces a scalar. So as the name suggests, the vector product produces a vector at the end. So if we have two vectors, let's say vector A and vector B, then their vector product, also known as cross product, is given by A cross B. A cross B. And the magnitude of the vector obtained from the cross product of vectors A and B is given by the magnitude of A multiplying the magnitude of B multiplying sine of the angle between A and B when they are placed tail to tail. So they are from the same point. When A and B are taken from the same point, tail to tail. Good. Now there are some things we should note in relation to the unit vectors. So I cross J will give us K. J cross K will give us I. K cross I will give us J. So there's something most of us use. I, J, K. I, J, K. So I times J will give us K. K times I give us J. J times K will give us I. In that order. So you can see that it follows it as it goes here. But if we are coming back in this way, let's see what happens. What will K times J be? What will J times I be? What will be K times J be? Like, we want to find out all that. So for vectors, when we are doing a cross product, it's not like scalar product where it is commutative. Rather, it is anti-commutative. So if I cross J is giving us K, then J cross I will give us negative K. That's the anti-commutativity of vector product. So K cross J will give us negative I cross K will give us negative J. But how is all this useful? Let's try some questions. I think it will be clearer. So let's try a question from physics. The electric field is 5 volts per meter I and the magnetic flux density 0.5 Tesla J in a region. Find the electromagnetic force on a 20 microcoulomb charged particle moving in the region with velocity 20 meters per second I. So we know the formula, the force will be equal to the charge times in a bracket the electric field plus the velocity cross the magnetic flux density. So here we are combining both the electric force and the magnetic force, giving us electromagnetic force. But how do we do V cross B? So let's identify our V. Our V is 20I. I'm ignoring the units for now. And our B is 0.5 G. Now we have to cross this. Now I cross J, we know it is K. Once we know that, we follow this thing IJK. IJK. So I cross J will give us K. K cross I will give us J. J cross K will give us I. That kind of thing. That thing should be known of it. So we get our K already. Then the rest is just multiplication of the numbers. So 20 times 0.5 will simply be 10K. 10K. Once we get the 10K, which will be our V cross B, we add it to the 5I. And multiply all by 20 microcoulombs. So 20 microcoulombs. So when we do that, we get into bracket 100I plus 200K all in micronewtons. That's the unit of force. And let's not forget our micro. So this is very, very simple. But here we realize that we're just given maybe a component in just I or just J, or straightforward. What if they give us all the three? That's why this question is here for us. So we have 2I minus J plus 3K and I plus 4J minus K. Now we can use the IJK system, but if we say we are doing that always, it will take a lot of time, especially when we are considering three-dimensional vectors where all the components are present. So we use this system similar to finding the determinant of a matrix. So under the I, we write 2, then J negative 1 for this vector, then K positive 3. Then for this vector, we write 1 for I, for J it is 4, for K is negative 1. Now we are going to do something. To get the component in I, after the cross, we have to ignore those who have I among the two vectors. So 2 and 1, we forget about them. Now, we consider these two and we find the determinant like we are doing for a matrix. So we'll do negative 1 times negative 1. That will be positive 1. Minus 4 times 3. That's what? 12. So you get negative 11I. That's all. Now, when you come to J, already we put a negative sign there. So it will be plus, minus, plus. Where the plus for I, J, K. So for the K, whatever we get, we negate it. Now, that one to ignore this one. This one is out. So we consider 2, 3, 1, negative 1. 2 times negative 1 will be negative 2. Then minus 3 times 1. So you get negative 5. G. Then plus. Now the K, we also ignore the 3, negative 1. So we get 2 times 4 minus 1 times negative 1. So we get 8 minus 1, 9K. So our final answer is simply negative 11I plus 5J plus 9K. This is how simple vector product is. So I urge you all to use AI tools to generate similar questions on vector product. Let me know how you fared. Thank you very much.